So guys, we are back and today we are going to discuss HDFS architecture in some basics, like not too much detail, but some basic idea that you should have about HDFS architecture. So as you can see, I have around kind of 4 nodes here. Now these nodes, just ignore these terms, master, worker, architecture, machine, cluster, Hadoop. I'm just explaining all of this. I have 4 nodes here which are of Linux file extension ext. Okay, and on top of each node and on top of each OS, like of on top of Linux OS, I have installed HDFS in each of these nodes. In each of these nodes, I have installed HDFS, and these nodes are in cluster because they are together. Okay, and connected through HDFS. That is clear till now. Okay, now listen carefully. One thing to note about here is that this ext ext file system present on each node, you can run the now there is HDFS file system also present in each node. Okay, but now you can run Linux commands and HDFS commands on all of these nodes. But the Linux commands only you can run. Let's say this has the Linux system. Now this node has the Linux system. So the Linux command only you can run on a single system. Okay, because Linux cannot be like distributed. Linux cannot be distributed. Okay, but HDFS commands you can run. You can run on a single system also, or you can run on no all of these combined, or some parts of these. Like you can like handle all the machines using the HDFS commands, but Linux commands you can run only on a Linux commands from ext you can only run on a single machine, but HDFS you can run on 3 machines, or you can run on all the machines. It depends on your usage of HDFS. Okay, till now it is clear. Now, now, now there is a kind of master and worker architecture. Master and worker architecture, in which we take one node to be a master and the other nodes to be a worker, or it can be one or more nodes to be the master and other nodes to be workers. But right now we will look at the case where only one node is the master. Let's say this node is the master and other are the workers. Now how does this master worker architecture work? Let's see. Let's understand some things. Okay, let's understand some things very deeply. First, the master node is called the name node. The master node is called the name node, and the other nodes are called the data nodes, and the other nodes are called the data nodes. Let's say I have my client here. This client, he sends a data fx.txt to my master node, name node. Now name node won't store this data. Name node won't store this data. What name node would actually store is metadata about this data. Metadata is data about this data. In what form? Let's just see what is happening. Let's just see. Name node stores the metadata about the data. Let's see how it is happening. Let's say my fx.txt is of 270 MB. Default block size in HDFS is 128 MB. So how many blocks it will make? 128 into 256 plus one more block to cover the remaining size out of 270. Okay, that is 14 MB. So total 3 blocks. Clear? Total 3 blocks. Next. That means my file fx can be divided into 3 blocks. That is fx I should write like this, that my file fx can be divided into 3 blocks, fx underscore b1 and fx underscore b2. It is just for representation. I am writing fx underscore b3, like 3 blocks. Okay, now each of these three blocks, okay, would the name node would direct these 3 blocks. It is used to control It is like what is name node is like a, it is like a control system. It is like a traffic police, you can say. It will control where the data is going to go. I just forgot to tell you this. Apart from the metadata, apart from keeping the metadata, it is also a control system. Mainly it is control system. It will direct where the data should go into each data node, where which type of data would should go into each data node. It won't keep a data. Name node won't keep a data inside it. Name node would not keep a data inside it, but it would direct for these nodes that where the this b1 should go, where this b2 should go, where this b3 should go. Note one more important thing here, that data nodes are not connected to each other. No, but each data node is connected to the name node. Each data node is connected to the name node. Okay, that's why I've drawn a red line over here. Each data node is connected to a name node. It is connected to the name node. Now name node would direct the data fxb1 to go inside fx data node 1, let's say, and it directs fxb2 to go inside data node 2, and it directs fxb3 to go inside data node 3 in such a way. Okay, I'm just giving an example. Name node could have decided that fxb2 should go inside data node 3 or fxb3 should go inside data node 1. The order could be different, but the main point is that the name node would decide where these blocks would go. Once fx is split into 3 blocks, this is also happening inside somewhere inside the the splitting is happening before wherever we won't talk about where the splitting is happening. It is like some map reduce kind of function, but name node would decide where these 3 blocks would go. Okay, in data node 1 or data node 2 or data node 3, or if 2 of them should go to data node 1, or if 3 of them should go to a single node. Okay, that things are decided by the name node. Okay, now there is a thing here, replication factor. Now what does it say is, this thing name node also decides, apart from deciding where the data should go, it also decides how the data should be replicated among the data nodes. Why replication happens? To prevent fault tolerance. In case our replication factor is 2, I'm giving you a very basic idea how the replication would take place. Okay, I will give you a very basic idea. Okay, fxb1 is in data node 1, so one copy of it is stored in, let's say, uh, data node 3. Okay, fxb2 is in data node 2. Okay, so one copy of it is stored in data node 1. Now fxb3 is in data node 3, so one copy of it is stored in data node 2. In this manner, each block has been replicated, each block of the file fx has been replicated 2 times. You are saying if our replication factor was 3, something else was happening, should have been happening. Each data node should contain all the blocks, but this is not happening. Our replication factor is only 2. That means each block will be replicated as many times as is the replication factor specified. Okay, I have bit my tongue a little bit strongly, that's why I'm having problem speaking, otherwise I won't have. So next, as you can see, each block b1, b2, b3 have been replicated 2 times at each. Okay, this is how basic replication is happening. Basic replication, we will see replication in more detail how it is happening, but this is a kind of basic idea you should have how replication is happening. Now what in metadata is happening, metadata is storing something like this data. Let me just choose some different color. Yeah, okay, that, let me just make metadata bigger, a little bit bigger. Metadata block is part of the name node. This block is part of the metadata block is part of the name node. Okay, It's not like separate from name node, it is part of the name node, inside the name node, you can say. Okay, so name node only contains metadata. This is inside here somewhere. Okay, this is inside here somewhere. It is not actual data that is being stored, but it's the data about the data. How it is the data about the data, I will just show you. See, so let's say we have fx file, and now we have block b1. It will store that block b1 is stored in data node. It will store this information that block b1 is stored in data node 1 and data node 3. Similarly, it will store information that block b2 is stored in data node 2 and data node 1. Similarly, it will store information that block b3 is stored in data node 3 and data node 2. That is how it is storing information about the data that is going. Okay, that is how information is stored about the data. Now, one important thing to like keep in mind. Now, this is the this like explanation. Now, if we have to say it in words, like what is happening in metadata, what is name node actually doing? Name node is deciding the file storage location in the data nodes, and it is deciding the mapping of the blocks, where the blocks are stored. It is deciding the mapping of the blocks where the blocks are stored, and it also decides one more function of name node is it will decide the replication factor. It will decide the replication factor whether it should be 2, 3, 4 or 2. This name node will decide. Name node decides the replication factor. You have to keep this in mind. One more thing, last thing to note here, that I should have told you in the beginning, but if you have stayed here, these data nodes always send a signal. Their way of communication is that every 3 seconds, they will send a heartbeat. They will send a heartbeat or signal to the name node that bro, we are alive. Bro, we are alive. Okay, bro, we are alive. In case of a data node failure, like data node 1 goes bad, one goes bad, so we lost the data node, the block b1 and b2 here, but still fault tolerance will work. Even if data node 1 goes bad, we know the replication factor was 2, so it got replicated in data. We can go to the what the name node will do. If data node 1 goes bad, it will search for the metadata where block b1 and b2, which data node 1 was holding, is present in other data nodes. So it will tell that b1 and b2 are stored in data node 2 and 3. So it will make another data node. Name node will make another data node and copy these data back to the other name node, like this name node, let's say data node 4, and b1, fxb1 and fxb2 will be copied to data node 4. Okay, that's how fault tolerance will work in a way. Now let's come back to what we were discussing. We have no problem. Now, how does name node know that this data node 1 goes bad? I'm just repeating. This data node is every 3 seconds it is giving a heartbeat or signal to name node about how it is working. If anything bad happens here, the data is not replicated properly or data is lost here. Aram se. See, if anything bad happens in this name data node, that some data node is so if anything bad happens, like in data node 1, let's say this b1 did not get replicated here, sorry b2 did not get replicated here, or the data gets lost, so every 3 seconds data node 1 is giving heartbeat or signal to name node that bro, I am alive, or bro, there is something wrong with me. If it tells the name node, bro, there is something wrong with me, then the mechanism that we will discard it, make another data node, and copy data from other data nodes using the mapping present in metadata. Okay, using the mapping present in metadata, that's what is happening. This is the thing that is happening in HDFS architecture. As simple as that. Okay. This replication is factor is determined by the name node. Name node determines the replication factor. Now let's see some. I will show you a table which is also important, that things would become more clear. Okay. Let's come to it. So what is the definition of name node? The master node is in the HDFS architecture that manages metadata and the file system namespace. File system namespace we will see in another video, don't worry about it. Data node, the worker nodes that actually store the actual data in the actual file data in blocks. Block B1, B2, B3. Data nodes are storing the actual data in blocks. Next, purpose. Name node tracks file locations, metadata, and directory structure, but does not store the actual data. Correct. File locations in the form of blocks where the blocks are mapped. Okay. And data node is responsible for storing and retrieving and replicating data blocks. How is it replicating? Like each data node is storing a copy of block of other data node, data node. Okay, like data node 1 had originally fxb1, but it is also storing the copy of fxb2 inside itself. Okay, in that way. Let me remove this cross. Just okay. Okay, this much is clear. Role of the name node is of a coordinator. It directs how files are stored across data nodes. Okay, that is we have seen. Data nodes performs read write operation as per name node instructions. One thing more, like name node, or like this metadata, not only the file mappings, or not only the mappings are stored here, but plus the operations, like what you want to do with the data, read, write, this is also stored inside the metadata. And name node will access this metadata and instruct these data nodes. Name node will access the metadata, what kind of operations it wants to perform, read or write, and instruct these data nodes, like to what the operation to perform, read, write, whatever they want to, whatever they have to perform on the basis of instruction given by the name node. Okay, if I repeat, just forgive me little bit. Okay, sometimes people repeat, it is okay. Data stores metadata like file names, permissions, and block locations. Okay, name node and data node stores the actual data split into blocks. This we know. Dependency, HDFS cannot function without a name node. Yeah, if name node goes bad, then we won't have the idea where to store B1, B2, B3. We won't have the idea. This storage won't be possible. At all. It will become half-assed. And also we won't know what operations to perform on each of the data node. Read, write, what we have to perform. What is the demand of the client? We don't know then. So in that case, there is a system called high availability HDFS. No, like high availability HDFS. In this, what thing happens now? Like there is a copy of name node, like not only one name node, multiple copies of name node are being made. Okay, in HDFS 2.0, 2 copies of name node are made, and in HDFS 3.0, 3 copies of name node are made, so that if one name node goes bad, the other name nodes can be taken as the active name nodes or the current name nodes. Are you understanding? Clear? Like it's just a method to avoid failure. Okay. HDFS can work with one or more data nodes. Data node failure does not stop the system. Yeah, we saw that because data has been replicated. Here, communication communicates with clients for operations and with data nodes to track blocks. block status. Okay, okay. So client will communicate. I will tell you, client will communicate with communicate with. Let me just, yeah. Client will communicate with name node to provide it the file which it wants to store, plus plus the operations that it wants to perform on a file that is already stored in the architecture SDFS, that is already stored in the SDFS, what operations it wants to perform. And the name node reads the operations from the metadata and instructs the data nodes according to the what it has read from metadata. It instructs the data nodes the instructions that it has read from the metadata and tells them to do those operations. Okay, that is the communication taking place. And it also checks the block status given by the data nodes, that they are working properly or not. If a data node is not working properly, every 3 seconds they are giving a heartbeat to name node, so the heartbeat would be like, it would be not working, it would be like fluctuating. Then the name node would understand that not fluctuating, like some kind of heartbeat or signal is given to the name node that I am not working properly, please replace me. Then name node will understand that yeah, we have to replace it, it is not working properly. In that way, now it communicates with the name node for what data node does is, it communicates with the name node for block operations and sends heartbeat signals. Same data node will take the operations, whatever the name node is communicating from the metadata, what operations it has to perform inside the data node. So it will take that data from the name node and it will communicate the heartbeat noted by the upper arrow. It will take in the operations and it will communicate the heartbeat to the name node that yes, the operations were performed successfully, I am working properly. These kind of information it will communicate back to the name node. Okay, let's say I have a write operation that was demanded here. I have a write operation that was demanded here, like from the name node. The name node said data node 1 to perform a write operation on fxb1. Now if the operation performed successfully, I will send a heartbeat 3 seconds later that yeah, that operation was performed successfully and I am completely working fine. This kind of thing, communication is happening between name node and data node. Okay, next is fault tolerance does not store redundant copies. Replications happen at the data node level, but in high availability setups, it does store redundant copies of itself. This is a non-HS set. This is a non-HS setup which we are talking about. That is a single name node setup where it doesn't store redundant copies. Fault tolerance handles fault tolerance, like what? How does data node handle fault tolerance? Through block level replication across multiple data nodes. This we know. Processes maintains and updates the file namespace dynamically. We will see this in some later video. Regularly updates the name nodes with block reports and health checks. Okay, health checks we will see later. This is the part of heartbeat. This block report and health check are part of heartbeat. We will see them later how this works. They work through fs image and edit log. We will see how they work in more detail in the next video. Okay, just keep patience. Some good example here. Like you can say, if you are in a hotel system, the receptionist is your name node. She knows where all the rooms in the hotel are and where all the guests are staying, but she is not staying in any room and she is not making any guest stay with her. Okay, she has the metadata about the rooms and the guest. Okay, the rooms are the data nodes. The rooms in the hotel are the data nodes, as simple as that. And the guest is the actual data blocks. Guest are the data blocks. that are being stored inside the rooms, that are the guests inside the rooms. Okay, you can see that. Now data node also like outside like the hotel rooms, data node, I said, rooms, the rooms in the hotel are data nodes storing the guest data blocks. Okay, simple. Now this was the basic of HDFS architecture that you need to understand how it works. Next video we might see HDFS architecture namespace in more detail, everything in more detail. Let's end this here for now.